In this video, we are going to be talking about two different types of intermolecular forces of attraction. But before we can talk about intermolecular forces of attraction, we need to first talk about intramolecular forces of attraction. That is, your general ionic covalent bonding. Actually, only covalent bonding is really necessary for this because molecular bonds are always covalent. So we will be sticking with covalent bonding. It's only one lesson, but I'm going to break it down into several videos because first of all, it's going to take a long time to learn this, and second of all, if I had to put this in one video, you would be overwhelmed and you would do worse on the quiz. See, after the chemistry midterm, the class average grade was not good, and Mr. Edelberg wants everyone to start off with a strong quiz in the third quarter, and I want that too. So I'm going to make this video divided up to give you more time to process the information. So we have dipolar bonds first. This is always between two polar covalent bonds. A bond is polar if it fails either the vertical or horizontal line test for symmetry. So if it is asymmetrical, then it is polar. If you have two polar covalent bonds, they will form a dipole-dipole. It's always asymmetrical because you always have two asymmetrical covalent bonds. So like HCl is an example of a dipole, HCl. And now another example is a hydrogen bond. So a hydrogen bond is, you need hydrogen, and it's only with three other elements: fluorine, oxygen, and nitrogen. This is because these are the three smallest elements on the periodic table. They're not exactly the three most electronegative though. Fluorine has 4.0 and oxygen has 3.4. But chlorine has 3.2 compared to nitrogen at 3.0. So why is nitrogen able to do a hydrogen bond but not chlorine? Because even though nitrogen has a smaller electronegativity, it is just a smaller element in general. So you need small elements. What it's going to do is that it's going to make the hydrogen more positive and the others more negative, and it's going to and like water or ammonia, these are examples of hydrogen bonds. So they can begin to pool together more easily, but it is still not covalent. By the way, intermolecular forces of attraction, those are always going to be weaker than ionic or covalent bonding. So I just want you to have that straight. So yeah, that's that video and a more depressing video coming right up.